I'm not going to pretend that the title isn't a speech-to-text snafu or whatever. It is. It's completely there because let's just conflate the entire thing into a joke because it is one. If everything's moving through time at the speed of light, basically moving the same speed as Sifu. However, let's actually talk about this. Moving through space is one thing. And he mentions in the video that talking about moving through time completely separate, and apparently everything's moving the same speed through time as light is, which simply means that everything is moving through time or progressing 1 second per second every second, or whatever you want to call it. Wow. But that's not what time dilation actually says! Time dilation says that an object, depending on its relative being near to a large space body, such as a planet or star or galaxy or black hole, anything that produces gravity, or if something is moving at a certain velocity, their time is different than stuff moving at a different velocity. This means that throughout the entirety of the cosmos, time is not moving steadily. This stupid motherfucking space-time video. It's not space-time, actually. It's SciShow. It's very weird. You're moving at the speed of light. I'm not gonna watch it. So here's the thing. That's the video. That's what you have to understand is the reference of all of this. But it's not just that video. It's everyone who's believing this strange idea that two things can be true at the same time. One, that everything is moving through space and time as basically at the same rate as literally everything else. And two, that there are pockets of space-time dilation, but also your velocity can simply create a space-time dilation. Let me explain how incredibly stupid this is. Go fast enough in the speed of light for light changes. That's not what they're saying. Oh, but it is. In order for time to dilate at all ever, every single function in that area of space-time needs to be going at a different rate through time as everything else. That means objects that are going through time at a different rate will also be seen as moving through space at a different rate. Why wouldn't they? So literally the same photon of light is going to travel the same distance, a different speed, depending on where it is. But Einstein said that light doesn't move at a different speed. It moves the same speed through everything. Doesn't matter if you're on a train or wherever else, you will measure light to be moving at the speed of c. It doesn't matter what reference, regardless of reference frames. That's what he said. So you can't have it both ways. You simply can't. Time dilation doesn't exist if the speed of light is considered and measured to be the same everywhere. Consider two different conveyor belts. One of them is going at, let's say, 1 meter every hour. It's really slow. But it's something you might see in a production line. And then you see another conveyor belt going 1 meter per minute. Well, that's literally 60 times faster. Meter per hour, meter per minute, very easy to understand. So, let's say that you, inside of this planet, in the atmosphere, because you're so close to its gravity, are moving at which of those two speeds? 1 meter per hour or 1 meter per minute? The assumption is that if time dilation exists, once you go away from this planet's effect of gravity, depending on your speed, you'll be going the speed of the other treadmill. That means that light will get to a place sooner than it normally would have in any other circumstance. The comment that I made on this video, kind of important. My first comment, at least. At some point he asks a question. I answered the fourth one. You have to watch the video to understand the question, or I will simply watch that portion of the video. The total account of all motion gives the full information of measurements, or going the same speeds in opposite directions versus the rotation of the Earth makes time a two-time distortion that equal negative speed and positive speed. Moving with the rotation of the Earth equals a positive speed. Moving against the rotation of the Earth makes a negative speed. That's what I mean by that. Versus the Earth's simply Earth speed, negative and positive makes sense, right? If assuming you're not moving on Earth, if assuming not moving on Earth is equal to 0, then moving in the opposite direction of the rotation of the Earth is equal to negative speed, which breaks reality. I realize I didn't say it that way. You can read what I said. I'm literally making this live stream moments after I said it. I'm not correcting myself. So, this video is 90% or more pure bunk. Okay?
Misnomer. It's more like a speed limit for light, because in a pure vacuum, light does travel at exactly c, or roughly 300 million meters per second. But if it's traveling through something like air or water, it interacts with all those atoms and gets slowed down. Except it also doesn't. From the light's perspective, it is always traveling at c, which is super weird. But do you know what's even weirder? You are also traveling at sea right now. And no matter what you do, you cannot...
Of course, he's not talking about through space, and he talks about how it's not talking about moving through space, but
travel any slower or faster than c. And how is that possible? Well, that's relativity for you, and it all comes down to the fact that we aren't just moving through space, we're moving through space-time. How fast do you think you're going right now? No, you're wrong. No matter what your answer is, you're probably wrong. Relatively wrong, at least. The problem is that your answer depends...
listen. If you talk about someone moving at a speed, the general consensus for most people is they would reference through space. He's not asking that. So therefore, we're not wrong.
Depends on what physicists call your reference frame, the specific frame of reference from which you make all your measurements. For example, right now you might be sitting on the toilet watching this video on your smartphone. So from your perspective, hopefully your speed is 0. But from the perspective of a sunbather on the moon, you're zipping around pretty quickly because the Earth is rotating relative to their vantage point.
Yes.
If you were in our studio bathroom in Montana, you'd be going 318 meters per second. Meanwhile, an alien...
I'm going to ignore that statement.
neighbor in the Andromeda galaxy might be watching our solar system with an ultra-high-powered telescope. And if they could measure your velocity, their result would reflect the fact that, yes, the Earth is spinning on its axis, but also it would include the Earth moving around the Sun at 30,000 meters per second, our solar system hurtling around the core of the Milky Way at 230,000 meters per second, plus the Milky Way's slow march towards Andromeda. So who's right? You, the lunar sunbather, or the Andromedan? Or some secret fourth answer? Well, one of...
My answer is the fourth answer. There's a reason for that. Because, of course, there can be more variables, more area of space relative to each of the galaxies even. We're also moving... we are moving through the cosmos. So, that generalizes it to the sum of all things. We are moving through all of this at some speed he didn't reference. But the point is, you're not moving still. So to say that a clock that was on the ground is moving stationary, and then two different planes go in opposite directions compared to the rotation of the Earth, Okay? One goes with the rotation of the Earth, the other one goes against the rotation of the Earth. There was an estimate to how much time dilation they would experience. But of course, there were discrepancies between their estimates and the actual findings. But the fact is that moving with the rotation of the Earth, it's the same as moving forward on a train. You cover a greater distance over time. Therefore, because you cover a greater distance over time, and the atomic clock works with light, and light moves at a constant speed, the extra distance means that light would have to bounce after a longer amount of time to do a second bounce. Its diagonal line would extend. So, even going 150 kilometers an hour on the plane in one direction will give you one result. In the other direction, it gives you a completely different result. And that's because instead of, in compared to the Earth's rotation, again, you added the speed and the extra distance traveled going in the one direction, and you negated the speed. You moved less while moving in the other direction. The other clock was more close to moving almost not at all. The one on the surface of the planet is still moving at the rotation of the Earth's speed, and the one going forward, the rotation of the Earth was moving at extra speed. The one moving forward had a slower time. The one moving backward had a faster time, because light didn't have to travel as far to make each bounce. And that's how time dilation truly works. Compared to the actual distance traveled, light will bounce a certain amount of time. And it's because of the delay between bounces that these clocks are completely broken. They don't actually work to show you accurate time. Apparently, it doesn't even matter what speed you're going. You're going to affect how the clock works. It's a very inaccurate clock in that way, that it will not be perfect, it will not be consistent, and you have to do calculations to compensate for your speed. But also, apparently, your speed doesn't matter. It matters your total distance traveled, which doesn't have anything to do with your speed, but your total speed, which only has to do with, even relatively, you could just say, the thing that I am moving compared to, which is the Earth, if its total distance traveled plus mine equals a greater number, then that means that light also has to be considered as moving a greater distance, and therefore it would take a longer time to make each tick of the clock. And if you go in the opposite direction, it's like going the opposite direction on a train. So let's say the train is moving 10 meters per second, or 10 kilometers an hour, whatever you want to call it. A normal type walking speed, one direction, so let's say north, and you go south down the length of the train towards the back of the train, relative to someone outside of the train, you will be seen as not moving at all. And it's this change in total distance that is important. It's not relativity as much, but it's the total distance of travel. Because it doesn't matter whether you go forward or backwards, your speed through the solar system and the galaxy and everything else hasn't changed. The only variable is your speed throughout, unless, of course, you consider that your position on the Earth also matters. Let's say that you're moving on the side, let's say you're moving on the side of the Earth that is rotating in the direction of the travel of the Earth around the orbit of the Sun. For the time that you're moving in that same direction of those two conveyor belts, which add up their speed, your total distance will be greater than if you're moving in the same rotation of the Earth, but in the side of the Earth that is rotated in the opposite direction of its movement along the orbit around the planet, around the Sun. I fixed it. So think about it this way. If you're moving on a conveyor belt, right? And then there's another wheel that conveyor belt is moving around. Relative to how you move through the total space that you have traveled, if you look at a tank tread as it travels, the bottom of the tank tread doesn't move relative to the planet. And the top tread is constantly moving forward. The top tread is literally moving twice a certain speed higher than the tank itself. The literal bottom half of the tread isn't even moving relative to the planet, because it's just gripping the ground. Unless you're spinning your wheels, you're not moving that tread faster than how the Earth is moving. Does that make sense? So blow it up to the size of the planet, and if you're on one side of the planet, when you're doing this test, you're actually gaining a negative distance traveled, which equals into just less total space traveled in total. As long as that's actually like capable of being comparable to how the planet is moving through the solar system. Now, in order to change stuff relative to the movement of through the galaxy, that's going to take a bit of a different thing, because your movement through the galaxy is also not regular. It's a sine wave. It's crazy that you're moving in a circle around the galaxy, but as you're moving through that circle, you're also going up and down. So depending on where you are in your travel through the galaxy, your motion is either directly in that motion, and moving up, or directly in that motion and moving down. Does that matter? I don't know. It could be a once per century or once per millennia thing. The difference between any of those segments of time. So that's really canceled out. We don't consider that actual frame of reference change because negligible. So please understand, when it comes to the atomic clocks that they have developed, in order for them to be correct about anything that they're saying, light has to go different speeds depending on where you are relative to gravity or your speed. This is not what is observed. Therefore, time dilation is a false understanding, it's bad wording, it's something, or it's complete, utter nonsense. Right now, it really doesn't make any difference where my phone is at any given moment in this segment of the video. Because relative to me, it's still the same distance. But it is moving through space. And ironically, I am moving at the same rate. The phone, being further away from me than my center, is moving at a greater amount of distance over time. However, it's still moving at the same rate of travel. Now, if it started to move like this, it's starting to move at a greater rate than I am, because it's actually moving around me. Or not. That's a reference frame being different. And the total distance that it traveled at any given point in time is difficult to keep track of because of when I decide to have my phone end up having it basically not move as much compared to my own rotation. You can understand that this can be very disorienting to someone actually trying to calculate the total movement of the phone. The photons of the phone and whatever else leading to my eyes, basically, because of the delay, the speed of light is so fast that I don't even notice a delay in where the phone is versus the light that's coming to my face. But once you're moving at a certain distance, that light delay becomes bigger and bigger. It becomes a fraction of a second. A noticeable fraction. So much so that atomic clocks will drift in a satellite depending on how fast the satellite is moving and their direction of travel relative to the planet. This is just how things are. There is, however, no such thing as time dilation. Unless, considering your speed, or I should say, the total distance you have traveled, which is only calculable when you look at the area reference and consider your actual distance over time, which is not the same as your speed. Is that weird? That distance over time is not equal to speed? But it is. It's very weird. It's not equal to speed at all. Your speed literally going in one direction, like I said, compared to understanding with a tank tread, and you can do this yourself at home. You can notice that any wheel that you roll, the part of the wheel that is on the ground doesn't move compared to the ground. Not nearly as much as the top wheel might move, of the wheel might move. When you're dealing with a tank tread, however, there's a whole section of the tank tread that's just not moving. It means that you shouldn't consider reference frames as in your speed or anything else's speed. You should consider the area of space you're moving in as a whole, a full measurement of distance, and then consider the amount of time you have elapsed. Honestly, I could be moving the same velocity up or down that train, but I will be moving a greater distance depending on if I'm moving up the train and if it's going forward, its speed is added with mine. And if I'm moving down the train and it's going forward, its speed is negated from mine. You have to take into consideration the distance I actually travel through space. It is the only thing that matters when truly relatively trying to figure out how things should be calculated. This is a slightly different perspective than I had before, where time dilation and all of that was easy to calculate if you just simply consider the fact that it took a certain amount of time. Although I said it similarly when I made other videos talking about the experiment of the planes. The total distance light had traveled in those experiments is of course greater in the one direction and less in the other direction. So that's why time dilation has been noticed in those ways. But again, it's not time dilation. It's just how much it bounces is only relative, it is only I've already said it. Light bouncing in the atomic clock will move a lesser distance if you're going the opposite direction of the rotation of the Earth, and also possibly so long as that direction is also in relative to if your experiment spans a certain amount of time, whereas considering the fact that the Earth goes around the sun in 365 days. If your experiment takes multiple days, then total distance traveling around the solar system comes into effect, right? That's why I said about the galaxy stuff. It happens over centuries and millennia. But for just a rotation around the sun, it's only the span of the year. So it's a fraction of the span of the year. If it's just within a day or whatever, or however long the experiment takes to do, then rotation around the solar system is not going to be too big of a factor for your total distance throughout space. That's what matters. So yeah. Are you moving the same speed through time as light? Yeah. That is to say, you're moving at a second per second. Doesn't matter if you're here, near a black hole, or just slightly outside of the gravitational effect of this planet. Say on the moon or something, or interstellar space, or interplanetary space. Your total speed is still relative to the solar system moving through the galaxies moving through the cosmos, and that section of the cosmos moving in the universe. If we are to believe that space is expanding, which it's not, it's also not doing that. It isn't. Like I said, the only way that time dilation does exist is if after you consider your total distance through all of space considered in the relative area, which in some cases needs to be the entire solar system. If you consider the space you have traveled in a certain distance, right? If there are discrepancies with your total speed relative to nearby planets and stars and such, light literally has to be going a different speed orbiting the planet. But light doesn't care about whether the object is orbiting. It likes to move in a straight line. So the interesting thing about light moving through a substance is that it has to bounce off of all sorts of other stuff as it's moving through the substance. It's still moving at its velocity, or it's still exerting the same amount of force through space so it can move itself through something. But in such an experiment like a photon of light was captured in a Bose-Einstein condensate, a very frozen piece of liquid, something. That the photon just basically stood there. Or, probably more correctly, it was trapped in such a way that it was forced to bounce pretty much indefinitely, so that its speed relative to everything else became zero. But it's still moving with the same amount of energy. But it is interesting to think about what would happen to light in a colder substance. Would it not move slower? And light in a hotter substance, would it move faster? Doesn't seem to be the case. And is there any way to make it so that light can increase its speed? Well, if you increase the movement of the substance, then light would be constantly be bouncing against that substance, and therefore it should somehow be able to go faster than its natural speed through a vacuum. The limit of the speed of light is just the limit of the mechanical function of a particle of light through space. Nothing more. Something capable of exerting more force than the light is able to exert. Because literally light doesn't have much mass at all. It's able to exert a lot of force compared to its size. Simply because of its interaction with the electromagnetic fields. If a photon of light is actually a particle like an electron. The fact that we were able to trap a photon of light in a Bose-Einstein condensate leads me to believe that it is actually a photon, a particle, not just an EM field disturbance. Because if a photon was a simple EM field disturbance, we could simply take a certain energy, turn it on, and make anti-light. Turn on this light, and suddenly the radiation from it makes all other lights go out. That's the theory. That if you apply a certain energy, if light is a electromagnetic field disturbance, then all you have to do is apply a certain electromagnetic field or like they say, constructive and destructive interference. A much more common concept. So if you have the ability to create the conditions for constructive and destructive interference, then you can dissipate light. I mean, at some point, the photon must stop moving and it must simply be absorbed by stuff that it bumps into. Although most of the light off my face isn't being absorbed, obviously. It's being absorbed a lot by my beard because there's a lot of places for it to get lost in and not bounce off of and back from because it keeps on moving. So, very dark here. Very light on my nose. Very dark in my nose. Very dark in my eyes. Especially my eyes. Because light literally can't go into my eye and then back out again. It gets absorbed by the structures of the inside of the eye. The cones and rods, as they were, sensors of the eye, forcing the light to basically have nowhere to go and nothing else to do. And that's why you have black in the middle of the eye. Nothing else is coming back. Photon speaking. So does that mean that our irises are Vanta black? Kind of. Kind of. That's pretty cool. It's also fascinating that we radiate energy all the time as thermal energy. That thermal radiation, a type of electromagnetic energy, is just emanating from us all the time. And all it takes is a sensor, and then we end up with this higher and lower amounts of this thermal energy, depending on the way you calibrate it. It's usually calibrated with hot things being red and cold things being blue, everywhere in between. That's neat. You end up wondering why, if something is able to emit infrared light, why don't we have ways of making solar cells that are capable of turning infrared light into energy? So we can take every bit of heat from everywhere in the world and turn it into extra power. And the more hot we make the world with engines and stuff, the more energy we would be able to glean off of it. Just a thought. Probably wouldn't work well, but I mean, of course it doesn't. We don't even have people talking about it as a concept, but there you have it. Not a brand new idea, just very not much talked about idea. I am almost 100% certain time dilation does not exist. I have to admit, most of the thing that makes me believe it doesn't exist is when I think about Kyle Hill's video about the ladder through a barn door thought experiment. Going at the speed of light, would the ladder be length contracted or time dilated? The answer is length contraction is either a physical phenomenon therefore obviously it would fit through the barn. If it's time dilated, that simply means its travel through the barn is going to be, and ironically, it's not just the ladder that would be traveling through the barn at that point. It would be the ladder and other things. Like the air, but we usually don't talk about the interactions of the ladder. But it's important to recognize that there would be interactions. It's important to recognize that physical objects moving at the speed of light, because a lot of what happens with matter is that its parts only hold together at certain speeds. It's ironic that you're holding yourself together and you're living on a planet moving at a speed that allows for life. But of course it does, because how else would you get here? It's the only way you would become and then have this experience of contemplating about that question. I don't know. Every time I hear people talk about electrons, they talk about the potential of moving as a wave. Ignoring the EM field is separate from the electron itself. It's like the water that the electron is moving through and exciting. So then as you shoot the electron through to the double slit, you're pushing an EM field bubble towards that double slit. The EM field then creates the interference pattern that then dictates most of what causes the electron to move into one of those channels towards one of those spots on the detector in that pattern. But of course, if you shoot a second one, it seems to move and land in random spots, meaning there is other things affecting the movement of the electron, not just the interference pattern, which channels it once it gets there, but some other thing, be it the actual complete perfect position of where it was shot from in the gun, if there's any difference whatsoever, which we assume, let's assume that doesn't happen. No barrel swaying with the electron gun, because why would it? Made to certain exact precision, that electron gun most likely does not move. It doesn't need to. Even the tiny little bits of force that could cause it to move don't make it move enough to make the electron move in its trajectory whatsoever, because they calibrated it really well, we assume. But also because it makes sense. The amount of force just would not make any difference. Everything holds together. So then the other thing that would randomize the electron's motion is interactions with the double slit walls, EM fields themselves, because everything's made out of protons, neutrons, and electrons. So the double slit itself has varying oscillating electromagnetic fields, which are the aura of the electron as it moves around the atom. So for every bit of those double slit walls, there are areas that, for the size of the atoms, are tiny oscillating little bubbles of electromagnetism. And these bubbles can deflect the electron into certain directions depending on which ones are pushing on it more. By reconstructing, if you send the electron at a set rate of speed, multiple shots per instance of time, and you keep on shooting, and you keep on taking a measurement, taking down like a picture of where it lands on the detector plate, how one will move here, one will move there, one will move here, one will move there, one will move there, one will move there, all of that, you can reconstruct the positions of all the electron bubbles throughout the double slit wall itself. And know the structure of the double slit on the atomic level. So if you have, for example, if it's made out of something that has all the same atomic structures, then, like if it's all carbon, then they're all the same size, right? But if you have, say, a different sized atom, then the orbits will be different and the size of the bubble and the variance, and the more chances that the electron will bump against that, just like a billiard ball, and end up in the position that it ends up with in the end result on the panel. So literally anyone playing billiards looking at that double slit experiment could have told you any of this. But for some reason we're still confused about it today. They say it's a pattern of randomness. Well, the electron is moving around the atom at 2 quadrillion atomic masses per second. So there are 2 quadrillion positions that an electron is seen as occupying every second as it orbits an atom, which is why it's so blurry. I mean 2.2 kilometers per second multiplied into the factor of 10 to the minus 10 meters per for the size of the area it's moving, right? 10 minus 10 in one direction, 10 to the third in the other, or however many, how is it? 10 to the sixth in the other direction? times 2.2. Yeah, it's 2.2 million meters per second. Because saying kilometers per second is silly. Saying meters per second is still silly because you're not talking about something the size of a meter. You're talking about something the size of nanometers, or a tenth of a nanometer, or less than that. When you get the units right on your measurements, then yeah, you have giant numbers, but you have a proper idea of exactly how many electron positions you should notice any given second. So it's like it's practically the same as saying the electron is vibrating around the atom, but it's not. It's just a crazy orbit, very similar to how planets orbit around the sun and how the sun orbits around the galaxy. It's not just an egg shape, it's also moving up and down and stuff. And I bet you the same thing is happening with the electron. Also, there's another thing. People talk about spin up, spin down, and half spin. Well, if I had a ball, I would give you an example. Oh wait, I have some kind of a ball. Where the hell is it? I know I have one. I don't know where I left it. Oh, there's a drum. That's neat. I have a Wonder Woman ball. I don't remember where I left it. Oh, I have this. So let's say that you consider this. This is spin 1/2. This is spin up. This is spin down. This is spin 1/2. It's literally what is happening. So the orientation of objects with spin 1/2, fascinating about that, because it literally never spins this way unless you're along unless you are in the same direction of travel. That's kind of how that works. That's why electrons have spin 1/2. Other things can have varying spins, clockwise, counterclockwise, and sideways. But you notice the difference between clockwise, counterclockwise, and sideways is nothing because I'm actually rotating my hand. The motion of the ball itself is the same. So spin up, spin down, and spin 1/2 is actually the same. It's just different directions of looking at it. Is how most people would think of a classical object. Like that ball. So then the question becomes, what's happening to the electron? What's happening to the protons? What's happening with the atoms? And other such things. Why would something be considered spin 1/2? Well, it's simple. The electromagnetic field is flowing through the electron, circling around the body of the electron, and then flowing through it again. It could only have one type of spin. It can only go sideways, because that's how the electromagnetic field moves. Other things that have spin up or spin down like that can do that because they have the ability to have the freedom of moving in all directions at any given time. So you could look at something and notice that, I mean, literally, if you have an electron and you magnetize it towards a certain direction, its spin 1/2 will look like spin up or spin down, which is really clockwise and counterclockwise. Although, I guess maybe it isn't clockwise and counterclockwise, and spin isn't actually the way that it is. It's more like, consider a toroid, or a donut shape, and it's rotating in on itself, like a conveyor, but in all directions. That's how that works. Maybe. So therefore, something with... Is it possible for something to be supposedly spinning while rotating in this other way as well? Yeah, you can be doing your own oscillation while your entire form is changing its orientation through space in all degrees. There's no reason why not, unless something is guiding you in a certain direction, like an EM field. Whatever.